Okay, hello everyone. Did I hear someone just complain that they were hot in Greece? That's an interesting complaint. So, hello, I'm Steve Smith, and I'm going to talk about how we can use the theory of constraints to make it easier to adopt continuous delivery. This is actually my first time in Greece, although I actually feel part Greek because I live in northeast London. And anyone who knows, there's someone laughing who's clearly been to northeast London and is Greek, possibly to meet family members. You know, one of my neighbours is Greek Cypriot, the other neighbour is definitely Greek. And they get on, which is good. I have a lot of other neighbours that are Greeks. My daughter's best friend at school, her parents are Greek Cypriot, so she spends the whole summer in Greek Cyprus. My taxi driver to Heathrow yesterday was like, you should totally go to Athens and meet my family. And I was like, that's a great idea. I'm totally going to find your family in Athens. I'll just walk around. I'm sure I'll meet them. It's a quiet city. So if you've not seen me speak before, you're in for a very exciting time. I'm going to have my usual flimsy arguments, childlike diagrams. We're going to have an unsatisfactory shallow dive into the theory of constraints. And there's not going to be enough time to cover everything in detail, I'm afraid. But I'm happy to take public questions, and if you feel more comfortable talking one-on-one, then please feel welcome to come and grab me afterwards, and I'm around tomorrow as well. So I'm a continuous delivery consultant based in London. I authored Measuring Continuous Delivery, which is a book about how to make better decisions when adopting continuous delivery. It's on LeanPub. I co-authored some other books. I'm currently co-authoring a book with Denise Yu, but we are blocked at the moment because she has a kitten. So she's favouring the kitten over working with me at the moment, which is understandable. And I'm a long-term associate of Equal Experts, which is a network of independent software delivery experts. Okay, so what are we trying to do? We're trying to increase the stability and throughput of production deployments until we can meet product demand. That's it, okay? If you don't currently have that, you're in a state of what I like to call discontinuous delivery. So who here today thinks that they aren't releasing to production often enough to meet product demand? Your product owner is unhappy, or you're a product owner and you're unhappy? Okay, the rest of you are liars. There's a lot of hands that didn't go up there and like... We're like Amazon, Steve. We release every 11 seconds. We only came to mock you. We don't need you. So, what's so hard about continuous delivery is that you're trying to make far-reaching organizational and technology changes in the complex adaptive system that is your organization. And you're constantly surrounded by people with half-baked solutions, off-the-shelf solutions that just don't work, and people telling you that Amazon's nothing to worry about, we'll go up market. You know, we'll design bathrooms instead of selling nails. They'll never look for us there. Like, that's totally going to work. Amazon, don't look there. So bearing this in mind, how can we identify the major impediments in a technology value stream like this, where we have a bunch of activities between code and customer? Normally they're to do with building stuff, testing stuff, and operating stuff. Okay? And once we've found those major impediments, how do we select the experiments that are most likely to succeed? The advice on how to implement continuous delivery has evolved over the years, as you'd expect, as we've learned more about the field. 10 years ago, Dave and Jez published the original book, and they recommended that we use the Plan, Do, Check, Act cycle by Dr. W. Edwards Deming, and we use that to gradually implement a maturity model based on configuration and release management practices. So half of that advice has stood the test of time and is awesome. So the Plan, Do, Check, Act cycle is a great way to run an experiment in a structured fashion. I strongly recommend it. Unfortunately, the other 50% of that advice has turned out to be pretty terrible. Maturity models are hocus pocus and need to die. This idea of like a linear step-by-step transformation, like we're 4 out of 5 on test-driven development, Steve, we'll be 5 out of 5 soon. Like this is completely at odds with like the idea of continuous improvement. Okay, so we need more advice than this. And I can tell you that from experience. Whatever you do, don't do what I did back in the day and use the Plan, Do, Check, Act cycle to try to automate the world, let's say. So some years ago now, I worked at a British telco on the network activation platform. We had 6 extreme programming teams. We owned 28 applications that I would generously call microlifts now. And we would munge them together to form a platform release, not often enough. And We had some really good stuff happening in those extreme programming teams, but beyond that, in our technology value stream, there were some interesting things happening. We had another team do a functional testing activity. They then did an integration testing activity. They said there was a 10-day test for regulatory reasons that I never challenged, which was a mistake perhaps. And then the operations teams did some black magic, and then we put it into production. We had so much good stuff happening before version control, but after it we had people burning out, we had people very unhappy, and there were a whole bunch of different problems. They included a Perl deployment script that often didn't work. The eagle-eyed of you may have noticed that's the first time I've mentioned a tool today. That's because tools inevitably all disgust me in time, and also that all tools are basically fine, except for WebSphere. Like whatever you're using, like it will be okay as long as it's not made by IBM. But Perl, yeah, like Perl for deployment scripts, that had a bit of a problem. And we had on-premise environments that were manually provisioned, so they were like wildly inconsistent. I think the time to build a new version of the platform was like 1 hour and 10 minutes. It was about 2 hours to do a release. Production releases were like 8 hours and had to happen overnight. So we had a lot of problems. I volunteered, as well as being a tech lead on one of the extreme programming teams, to be the continuous delivery person to build this automated deployment pipeline. And I calculated that our lead time, our time from code to customer, was 14 days. And I invented a target lead time of 14 days. So a couple of mistakes there. Straight away, didn't find a product owner, didn't look hard enough. And also, a deployment pipeline should be an output, not an outcome. It should be an artifact of the process, not the process itself. So not off to a good start there with hindsight. Okay, so rather than a maturity model, we should be thinking about capabilities. Okay, we should be thinking about the technology and organizational pieces we need to have in place in order to achieve the throughput that we need to have. So here's like a list I made up of the kind of technology changes, capabilities that we'd like to have. And the boxes in white we didn't have on network activation. The boxes in blue we did have. So for example, we had trunk-based development and continuous integration happening. And yes, that does mean that every member of those 6 development teams was committing to trunk at least once a day. Continuous integration is a practice, not a tool. It's nothing to do with a build server, and you can put CI in a URL, but ultimately everyone should be committing to trunk once a day, which is pretty hard. But we had that, we had some good stuff happening. After 18 months, we had more good stuff happening. We built a fully automated deployment pipeline for our 28 applications. It also covered a further 70 applications that over time just emerged and needed a home. We built an automated database migrator, and we used branch by abstraction with consumer-driven contracts and feature toggles to gradually decouple these 28 applications so that it was easier to test them independently. These are some of the organizational capabilities you might like to have, and we had a couple in place, the ones in red. We had devolved decision-making. The extreme programming teams could decide things for themselves. They were empowered to make choices. And we also had continuous change reviews in place because we had pair programming like 95% of the time. We made some limited headway here. We got to a smaller batch size by gradually decoupling applications. And we also introduced like change traceability rather than trying to do governance through lots of spreadsheets. People could look at this like automated audit trail from the pipeline and understand what had happened. So that took effect beyond development, which was good. But after 18 months of hard work, after bringing the platform build time down from 1 hour and 10 minutes to 2 minutes, bringing platform release time down from 3 hours to 43 minutes, our average lead time was 31 days. So after 18 months of work, we'd saved 3 days. We hadn't saved the 20 days that I envisaged, stupidly. So by my yardstick for success, this program failed. To be more accurate, I failed. We never knew what the major impediment was, what was preventing us from going faster than 31 days. There were some theories flying around. Some people said that 10-day integration test took longer than 10 days. Some people said the operations teams were doing stuff that we just didn't know about and was quite time-consuming. I didn't know what it was. I was too busy playing product owner, developer, architect, and tester to worry about what this big problem might be. All right. So what advice do we have today that would have been useful in that kind of scenario? In 2015, the Lean Enterprise book came out by Jez Duran-Maleski and Barry O'Reilly. It's like somehow underrated. This is just a great book. It covers product development. It covers continuous delivery through the same prism, which is the improvement charter. It talks about using the charter to incrementally and iteratively improve towards a goal. And that's something that you do with existing ways of working. It dovetails beautifully with a continuous delivery program. So this is like absolute gold dust. And then in 2018, the Accelerate book came out by Dr. Nicole Forsgren and Jez and Jean Kim. And that gave us, well, it gave me some great confirmation bias. I think it gave us, as a whole, like a statistical underpinning for the continuous delivery practices that we all know and love, and some adjacent essentials like lean management. Who here would have thought prior to Accelerate that trunk-based development would be a statistically significant predictor of high IT performance and organizational success? Just me. Oh, the other people that have done trunk-based development, thank you. We can all be friends afterwards. Okay, kids, if you want to make money, don't do branching. Okay, so the continuous delivery book gave us the plan, do, check, act cycle. The Lean Enterprise book gave us the improvement charter, and Accelerate validated our direction of travel. But I don't think this advice is enough. So in 2018, I finished measuring continuous delivery. I famously told my wife it would take me 6 months of 4 nights a week, 11 p.m. to 2 a.m. to do this book. It took me 2 years. If anyone here is thinking of writing a book part-time, come and see me afterwards and I'll give you some free advice, which is to write some blog posts and then go out and spend time with your significant others. But if you do, very forgiving wife. I've completely distracted myself now, which was exactly the intention there. This is excellent. I don't know what I'm doing. So, in my book, I pointed out that we need to make it easier for folks to adopt continuous delivery, folks that haven't done it before. We need to give people a way to visualize deployment throughput so that they can, uncover insights for themselves. We need to help people identify the major impediments in a technology value stream. And we also need to make it much easier to identify the technology and organizational changes that are likely to reduce those impediments quickly. So how do we do that? Well, we can use a deployment throughput indicator to visualize the progress of a continuous delivery program. This is a technique that I cooked up from a couple of years of working in the UK and wrote all about. Basically, what we do is we visualize our lead time against our interval. We visualize how long it takes us to do something and how often we do it. So in this case, we're using network activation as our example. We're applying a technique from 2017 back onto data from way back when. So there's going to be a lot of hindsight bias here, which I'm very excited about. We've got our x-axis, which is our 18 months of work, and our y-axis is calendar days. If we have anyone here who's colorblind, then come and chat to me afterwards, and we'll find a way to share this information in a way that's more accessible to you. We have the orange line here is our average lead time, our time from code to customer, and our green line is our average interval, the time between production releases. So I kind of wish we had this back in the day, because straight away we can see some very obvious things that are crying out for attention. For example, for the first year, our lead time was greater than our interval. That is unusual, and that is not a good thing, okay? That means we're doing something more often than we can make it. We were releasing to production every 21 to 28 days, but it took us 34 days to build and test it, okay? So no wonder we had people stressed and burning out, because we were sprinting just to stand still for over a year, and probably before this time. This is something we didn't know at the time. We then had a improvement to 28 days. That wasn't a real improvement. That was us crunching to get some releases in before a Christmas change freeze. I do love change freezes. I think about them all the time. But one thing we do have is we do have a 3-day improvement here at the end. We did get from 34 to 31 days, and we didn't know why. Interestingly, we can see at the end that the interval and lead time start to match one another. So I like to think that using that deployment pipeline, eliminating toil and rework, created like a sustainable pace. That's my story, and I'm sticking to it. So, to find the impediments in a technology value stream, we can use the theory of constraints. So the theory of constraints is a management paradigm from Dr. Eli Goldratt, and it's all about improving organizational throughput by optimizing a small number of constraints in a homogeneous workflow, I should say. So who here has read The Goal? Lots of us. Okay, please, more of you read it. It's just a fantastic book. I always read it at least once a year. I always pick up something new from it. It's like a lean business management novel thing. It's kind of hard to describe. But in it, Dr. Goldratt talks about how to apply the theory of constraints to like a failing manufacturing plant. And its central premise is that we need to iteratively increase the capacity of a smaller number of constraints until we can balance the flow of work through to customers. This is applicable to continuous delivery because a technology value stream should be a homogeneous workflow. In design and development, variability is of economic value, and you want something like the principles of product development flow there, okay? But in a technology value stream, you want continuous delivery, you want the theory of constraints, you want to drive out variability, you want to make things as deterministic as possible. Okay, so the theory of constraints teaches us that a non-constraint is any resource with capacity greater than market demand. That a non-constraint is controlled by a constraint elsewhere that we may not have identified, and increasing the capacity of a constraint is a waste of time and money because it won't do anything to address the queue of work in front of a constraint, nor the starvation of work behind the constraint. So what does this mean in terms of continuous delivery? Well, in our context, it means that we will always have a number of unconstrained activities that take less time than our target lead time, and they can only happen as often as a constrained activity elsewhere will allow. And trying to speed them up is wasteful. Okay. We also learn from a theory of constraints that a constraint is any resource with capacity less than or equal to market demand, that it controls the level of utilization of other non-constraints, and losing an hour at a constraint is a terrible thing because you lose the hour for the whole organization and you can never get it back. So in terms of continuous delivery, we can say that if a team is in a state of discontinuous delivery, in its technology value stream, there will be at least one and at most a few constrained activities that are taking too long for your target lead time to be accomplished. Maybe there is one activity on its own that is longer than your target lead time in duration. Maybe there's one or two that just kind of tip you over the edge, but either way, there's a constraint there. So if you notice in this visualization, you'll see that the activities after the constraint only have the capacity of the constrained activity itself. They can't go any faster, okay? So those people who put their hands up at the start were like, yeah, well, I'm in discontinuous delivery and I'm really enjoying it. I'm willing to bet that you have this. And I'm willing to bet that your constraint is not what you think it is. It's going to be something strange that you've never thought of. And when you find it, it will completely change the way that you think about software delivery in your context. Okay, so what examples of constraints might we find? So here are a couple of obvious ones. Handoffs. Whenever one team hands a release candidate over to another team, maybe a testing team to an operations team, maybe a development team to a testing team, whatever you like, that's going to create a queue between those two teams, and those release candidates will be waiting for the second team to pick up the work. That could very easily become a constraint. I've certainly seen that happen before. Environment contention is another good one. When you have multiple teams all wanting to test in the same environment, they may well end up backing up on one another and queuing up as one, maybe only one team's allowed to test at a time because the way you provision test data sucks. And also staff illiquidity. Perhaps you have only a couple of key staff members that have some really critical skills, and without them, stuff can't happen. Perhaps you have only one tester that knows how to do performance testing. Perhaps you have a release manager that only they are able to write the release implementation plan or run a cab. Perhaps there's a key developer that has to fix problems that you always have. Okay? But there are many other examples. Who here can think of some constraint that they've seen before other than these? You're allowed to say end-to-end testing, that's the obvious one. I don't know, why didn't I put that up there? Like, if you're doing end-to-end testing, that's probably your constraint. It's a terrible idea. What else have people had before? Okay, we'll stick with end-to-end testing then. Okay, so if we apply like a theory of constraint lens back onto that network activation data, can we identify what the constraint was many moons ago? So this is like a per activity lead time breakdown. This is showing where those 34 days we're going every 6 months in our 18 months. Our x-axis is again the timeline, and the y-axis is calendar days. And in each case, the blue area is the first functional testing activity I talked about. The red area is the integration testing activity, and the yellow area is the production activity. That nice green dotted line is the target lead time we're trying to achieve. And immediately we can see that the constraint is the production activity. It's much longer than everything else. And again, this would have been awfully nice to have, because we never looked at the production activity. It never occurred to us that that was our constraint. All of our activities were focused elsewhere, pretty much. All right, so what the hell happened here? Well, we can split up the activity time into process time and queue time. The queue time for an activity is the time we spend waiting for the activity to happen. The process time is the time we spend actually doing the activity. So the lighter colors here are the queue time, and we can see that over time the lighter colors for testing are removed. That's because we eliminated the queues in front of functional testing and integration testing. And that wasn't done by a deployment pipeline, that wasn't done by me. It was done by my iteration manager, who basically hassled testers to start their testing as soon as possible. Not by coincidence, that saved us an average of 3 days. So you may recall we had an improvement from 34 to 31 days. This was the thing that did it. And again, I only learned this 18 months ago, which it would have been nice to know. Okay, so clearly here, the lighter yellow area, the queue time in front of production is our constraint. And that's something that we just never occurred to us. We can see that it's always around half the time. Okay, so of our lead time, we spent half in between testing finished and do the production release. That invisible queue between testing and, between operations actually and production release, that was caused by a process that we entirely owned ourselves. Our release manager had to schedule production releases in with an upstream billing system. And they had some pretty painful paperwork, so they would agree the production release dates a few months in advance. So what that means is that we've got someone doing something with the best of intentions to make their lives easier, and I probably would have done the same thing. But if we think about it holistically, what's happening is that we're locking everyone into discontinuous delivery before we've even picked up a keyboard. We've guaranteed that we're going to hit our 34-day lead time. And that's because if your testing runs too late, you'll delay a production release. But if the testing finishes early, do you bring the production release date in? No, you don't. You sit on it, right? Because the date's already been agreed and the paperwork is painful. So all of our efforts over time, all they did was boost this queue, unfortunately. So I had great fun working at this company. I learned an awful lot, but I do think about that from time to time. And certainly now when I work with a new client, one of the first things I do is say, can I meet your release manager and can I be friends with them? And can I learn about their paperwork, please? Okay, so how does the theory of constraints work? Let's look ahead. So with the theory of constraints, we use the 5 focusing steps. So we identify a constraint, we exploit the constraint, we subordinate everything else to the constraint, we elevate the constraint, and then we repeat the process. This helps us not only find the problems, but also pick the practices in the continuous delivery canon that are most likely to help us reduce those constraints. So first of all, identifying the constraint means calculating a target lead time as like a proxy for product demand. And then you need to identify the activity that takes too long for that target lead time to be accomplished. An example. So let's assume that we're all working together in a very small team of continuous delivery consultants, and we've identified a performance testing environment as our constraint because there are too many teams just piling into it with their tests at any given time. And it's probably on-premise because, like, what the hell. Exploiting that constrained activity means saving time. It means eliminating idle time, it means eliminating defective items, and it means eliminating unnecessary items. So with our performance test environment, there's a lot of things we could do here. We could automate the deployments, automate the performance tests, reduce the time it takes to run the tests. We could increase the number of testing slots, maybe to run overnight. We could change tester lunch times so that there's always someone available in case the environment breaks, because you don't want it down for even a minute, because this is the constraint, and a minute lost is a minute lost for everyone. What else might we do? I'll save some others for Elevate. Okay, so the next thing we want to think about is subordinating everything else to the constraint, and this is something that people can find a little hard. This means limiting the frequency of release candidates to match the constrained activity. Okay? So if we can only get through performance testing once a week, we should produce a release candidate once a week. Because if we do loads of testing beforehand, it's not going to go any quicker through performance testing. And we're just going to build up queues of work in front. So the best way to achieve this is to use WIP limits to ensure that developers aren't producing too much code too quickly. And when we get to a point where all of these swim lanes on a board have tickets in a waiting for performance testing state, should the developers start writing more code? No, Steve? Good. They should help the tester, because that's the constraint. And if your developers don't like that, then you should tell them that writing code means that they're creating liabilities, not assets. That always goes down well. And I'm a developer. I remember down north taught me that, and I was just like, that can't be true. Okay, so elevating the constraint. This is where we spend money to create time. So we've exploited the constraint, you're just trying to save time. With elevating, we're trying to create it. With performance testing, we might hire more testers. We might do some more training for our testers so that more of them can do performance testing. We might buy better hardware to chuck at our performance testing environment. You might be thinking we could build a second performance testing environment there. Like, please don't do that. I don't want to turn up at your company and say, perhaps you don't need PF1 and PF2. Like, that's happened before. It wasn't nice. So, all right, repeating the process. This is where we assess the impact of the changes we've made, and hopefully we've made our change in a plan, do, check, act style, like create a hypothesis, make a change, observe the impact, see if we met our hypothesis. We keep doing this until the flow of release candidates is balanced and we can deploy frequent enough to meet product demand. Then you're in a state of continuous delivery and you can have a party, like, well done you. Of course, removing that internal constraint means inevitably that you will then serve as an external constraint, either upstream in product design and development or downstream in customer sales, but like, enjoy your party. That's a problem for tomorrow. All right, so I can tell you from experience that using the plan, do, check, act cycle with the theory of constraints can have a really positive impact on how you approach continuous delivery. About 18 months ago, I worked as a continuous delivery consultant at a media organisation in London. They had the kind of problem that I really like. They phoned up a company I worked with, and they were like, can we talk to the tour guy of YouTube, please? And they were like, yeah, we know which guy you mean. And they were like, we've got this multi-team on-premise monolith. It's on top of this vendor product that we can't get changed. The on-premise environments are always breaking. Like, what do you think we should do? And I was like, I think I should come and visit. This sounds awesome. I love the sound of this. And yes, there were 6 teams working concurrently in one big mono repo. And beyond the development teams, there were just a ton of challenges. Okay, so there was firstly there was this integration testing activity from a different testing team. Then another testing team did a release test activity, and then there were some operations teams that did some black arts and did their production release. There were Linux environments that were manually provisioned and wildly inconsistent and constantly changing. Release candidates were mutable, like after testing, like a release candidate might be changed. That was always my personal favorite. They used to keep me awake at night, that one. I was like, oh, hello 2005, I thought we'd stop doing this. Okay, let's do it all over again. Releases ran off a Jenkins script to a WebSphere cluster that often needed restarts. Like Jenkins, that's fine. WebSphere, like if you really must, of course you've got WebSphere. You've got everything else. Production releases took 8 hours. They needed a 60-step semi-automated release implementation plan. The kind of spreadsheet other people don't want to look at. It's like looking at the sun. Whereas I'm like, I really want to read this document. Like, please give it to me. Quicker, quicker. I want more. We had multiple different testing teams doing lots of different suites of end-to-end testing because of Conway's law. I like to think of Mel Conway sat in an armchair just laughing at different teams doing different wacky things. This was like a super complicated organization. It was a complex technology landscape that was constantly shifting under our feet, and the failure blast radius was pretty big. Like if you made a mistake, things kind of went kaboom. This was just a huge challenge, the kind of thing that I really like. So the big weapon that we had was we had a product owner who had been a test and release manager for 7 years and knew this inside out. And they were very clear that currently releases happened every 3 weeks. They needed to happen every 1 week to meet product demand. They had been told by their peers that even 3 weeks was too fast and nothing could be done about it. And on top of that, it was all probably going to be replaced in 2 years by this awesome new cloud microservice thing, so they didn't want to boil the ocean. So this is, like music to my ears, because I'm all about not boiling the ocean. I'm all about understanding the problem, looking at the options that we have, applying them, observing the effects, and then iterating on top of that. So for the first 2 months, we built some visualization tools. We asked a lot of questions about release management. I made a lot of effort to get to know the release manager and to know their paperwork. And we avoided committing to any really substantial technology changes because we were frightened of breaking stuff that we didn't understand. We knew that our interval was 21 days, and we learned that our lead time was 14 days. So we were releasing to production every 3 weeks, and it took us 2 weeks to do it. So we had a week of headroom. And we built out our lead time visualization, except this time we built it at the time of doing the work, not like 10 years later, when it's too late to do anything about it. And in our case, we could see that our constraint was clearly the second activity, release testing. Again, blue is the first functional testing activity, not too big. Yellow is production, not too big. The red one is like, oh, that's too much. That's bigger than our target lead time will allow. So the release testing activity was, it was really quite something. Has anyone here seen a UK show called Peep Show, where there's an episode where one of the guys goes into a party and comes out straight away and goes, I never want to look behind that door again. I want to go somewhere safe and cozy and never speak about this again. So yeah, spending time understanding this release test activity was a bit like, but afterwards you're like, we're just not talking about this. There was a lot of brittle end-to-end tests. There was a lot of well-intentioned people working really hard. There was a lack of change control, lots of deployment failures, on-premise servers were running out of disk, running out of memory, or running away. There was a lot happening here. And we estimated it would take us at least 3 and maybe up to 6 months to work with the 5 teams that all claim to not own this environment, to work with them to improve this, to get it down to around a day. And that 3 to 6 months estimate, we didn't have a lot of confidence in it. So I then had a good idea. I hypothesized that our release test activity would not be a constraint if our target lead time was 14 days, not 7 days. So we were releasing every 3 weeks, and it took us 2 weeks to do it. So when we raise our target lead time to 14 days, we can see that release testing is not the problem. In fact, there is no the problem. It fits underneath. So you may remember me mentioning the improvement Carter earlier. The Carter is all about understanding your current condition, your long-term goal, and then iterating towards it. So this is a good example, okay? It currently takes 3 weeks. Long-term, you want to get to a week. But don't shoot for the moon. Just try a stepping stone. So I went to the product owner and said, we can get to fortnightly releases in a month with 3 or 4 changes, or we can get to weekly releases in 3 to 6 months with lots of changes that might go wrong. And to my delight, the product owner said, let's go for fortnightly. And there's a great story in the goal about how Expectations of customers are adjusted based on what the plant can and can't do at a point in time. This is exactly what we're trying to do here, okay? You should be able to negotiate a target lead time based on what can and can't be done. So we met with the operations team, showed them this, invited them into a conversation and asked for their thoughts rather than try to impose some top-down crap on them. And they agreed with us that weekly releases were desirable, that release testing was the constraint, that fortnightly releases were a good idea. But then they told us about a second constraint that affected any greater speed than 3 weeks, which was the release manager themselves had an enormous amount of responsibilities. They chased all the development teams for a third-line support rota. They chased 3 different teams for release notes. They had a day job in product price management on top of release management. They ran a cab. They did the release implementation plan. They did the overnight release. Like, they did everything. And the reason that preparation time didn't show up in a visualization like this is because the data was not recorded anywhere. This release manager just did the work and thought it was okay that they had such a huge amount of work on. So the operations teams agreed that we could move to fortnightly releases provided that we could reduce the workload on the release manager. And this was music to my ears because that release manager was the constraint. We had staff illiquidity. I wanted to concentrate only on changes that would help that person. So here is a technology capability model for MediaTek, and it's very similar to network activation. And again, we had trunk-based development with continuous integration, and that's because we were using subversion, in which branching is horrible, so you try not to branch and talk to each other like grown-ups and design things together. Don't you miss the old days where we had bad tools that encouraged us to do good things, rather than now when we have good tools that encourage us to do bad things by default? Is that just me? Oh, we have one guy, 3 of us, we're going to be friends tonight. This is good. Everyone else? No. I'll go back to the UK with 2 friends who don't do branching. That's good to know. And then we'll all make more money because Accelerate tells us. Like, we can phone Dr. Nicole and go, we're going to make money. This is awesome. All right. So, bearing in mind everything that we've just said, which of these white boxes do we think we flipped? Which technology change was here did we make? Do you think we did automated database updates? Do you think we did a deployment pipeline? Do you think we did any of these? The answer is we did none of them. Even though I wept at times and had to hide under the desk when people came around saying, when are we going to fix this whole mutable release candidate thing, or why does WebSphere keep running out of memory? We did absolutely none of these because the 5 focusing steps clearly teach us to only tackle the constraint. And it didn't feel good, but we didn't do any of these because introducing database updates would not have helped the release manager. A deployment pipeline would not have helped the release manager, and neither would exploratory testing. Even though all of those things are of value, don't get me wrong, we wanted to get as quickly as possible to something that would help our release manager get us to fortnightly releases. So, here are our organizational capabilities. We were lacking some really key things. We had a small batch size, and we had to make some changes here to help our release manager. And we made 3 changes to get to fortnightly releases over around 6 weeks, I think it was. So first of all, we exploited the constraint by creating a shared call-out rota. We just created a spreadsheet with every development team on. We did it up to 6 months in the future. And a colleague of mine went to all of the 6 teams and said, do you want to get to fortnightly releases? And they were like, yes, we do. And then my colleague said, here's the deal. You need to put down names for people on third-line best endeavor support for the next 6 months. And you need to do it within 3 days. And after 3 days, it was done. And our release manager was delighted because we had lifted them out of a really significant amount of toil. And even after only 1 week of not writing chase emails to delivery leads saying, please fill in the rota, it really made a big difference in the quality of their working day. So that got us off to a great start. And just a really daft little change that had a really positive impact. The next thing we did was we exploited the constraint again by writing an automated release note tool. And if that doesn't sound very glamorous, it's not. I had to persuade, bribe, plead with the developers to actually do the work in the first place. There wasn't very much Kubernetes involved. It was a bit of Python and a bit of Jira. It wasn't, the cool thing to do. But previously, there were 4 different teams producing 3 different release notes, which our release manager had to check all matched up, and often they didn't. We built one tool. I spent a number of weeks sat with people drawing lots of diagrams and explaining how this thing would help in the long run with fortnightly releases. And we found that not only did it cut out a whole swathe of errors, but also it gave a release manager much more confidence in the release candidate approaching production because they could see a release note much earlier. And finally, we elevated the constraint by finding other staff members to take on some of the responsibilities of the release manager. We found some people to do the overnight releases, we found some people to do some of the work around CAB, and it worked. This is the deployment throughput indicator for network activation. This is over a 6-month period, and the y-axis is again calendar days. In this case, the orange line, our average lead time, stays at 14 days, and that was the plan. We were trying to protect the lead time. We weren't trying to reduce it. We were trying to reduce the time between releases, and we did that. You can see, first of all, there's this little drop in the green line in the average interval. That was an experiment that we ran with Plan, Do, Check, Act. We agreed as a group, my team and the operations team, to do 2 fortnightly releases back to back. And our hypothesis was that it would not introduce any new production problems. And it didn't. And shortly after that, we moved to fortnightly releases for the long run. I checked in with this company quite recently, and they're still on fortnightly releases. And it only took us a month. We didn't boil the ocean. We didn't have to break anything. We went in, we fixed some stuff, we understood problems, and we got out of there. So using the theory of constraints here really helped us get to fortnightly releases, which was an option our product owner hadn't previously considered. And actually they were delighted by it because after we got to fortnightly releases, they learned that that was actually sufficient for product demand. That boost from 3 weeks to 2 weeks was much greater than expected. And as a result, the work to go to weekly releases didn't happen. That really tricky release testing activity is still there, and it's still really painful, but it's always fixed in time. So we saved that company 3 to 6 months worth of development effort by doing something much quicker and much more focused. So everyone was happy once we actually looked for a constraint and tried to fix that before anything else. Okay, I have some key learnings for you. So implementing continuous delivery is really hard. It's important to understand when to make a change as well as how to make it. The theory of constraints can help you understand where you need to make a change and suggest when you should do it. And I really want to stress that you don't need to automate the world. You need to just iteratively reduce your constraints until release candidates go as fast as your product folks would like. And once you've done that, that's continuous delivery, even if you're using WebSphere. It's fine. Okay, here's a couple of things for you to try back in the office. I nearly said try at home then. Try back in the office. So, first of all, you can establish your target lead time by going to talk to your product owner and saying, hello, Sue. I'm looking at a chair, I don't know why. I was going to look at the guy in the front row, but clearly he's not a Sue. So, hello, Sue. Just trying myself again. Hello, Sue. How often would you like to release? And whatever they say, even if it's hourly and you're currently doing monthly and that puts you in tears, that's the goal. You don't have to go there in one step, but that's your goal, okay? All right, next, you can find your constrained activity. Once you know that there is a constraint and you accept that, it's not so hard to find it. If you have quantitative data, you can just look for the activity that takes up too much time for your target lead time to be accomplished. If you don't have any quantitative data, that's okay. Look for the activity with lots of release candidates piling up in front of it and not very many release candidates doing stuff after it. And also, there are lots of people arguing about it. So if you're doing end-to-end testing, it's probably that. You've probably got a whole bunch of releases waiting to go into it, not a lot of work happening after it, and a bunch of people arguing about how it should be done better. Right? Whenever you find that kind of scenario, that's the puppy. And finally, you can run experiments to save constraint time. Just think of some changes that will reduce that constraint. You'll be surprised how many options you can think of. And I promise it will work as long as you find that constraint. Okay, so thank you for having me. When you come to do your speaker feedback, do you do it through the app? I don't do apps. I haven't told the organisers. I've not logged onto it and I don't intend to. I'm kind of allergic to apps. But when you do the speaker feedback, I've said too much. I won't be allowed home now. It's okay, you can say he talked too fast. You can say, he didn't mention DevOps, I wanted him to. You can say, I really admired the way he didn't talk about DevOps because it's a cargo cult devoid of little meaning despite the original best intentions of the DevOps philosophy. Or you could just say my absolute favorite, which was, his sense of humor is far too dry for me, and I'm from Denmark. So, thanks very much for having me, and I'll see you around. Thank you.
Thank you, Steve. Although we do have time for 3 questions, so if you have anything to ask Steve, here's your time.
Hello.
Hi.
Hi.
Thank you very much. Actually, it's 3 questions in one. Sorry about that. Yes.
Uh-huh.
My first question will drive the other ones, I guess. So it's when you say you measure lead time, against what? It's against features, business features, or bunches of code that reach to production?
None of that. Just think about it as a release candidate. So what do you ship to production? Like a versioned container?
Okay.
I'm asking, what's the thing you send to production? Is it like a Docker container or something?
Sorry. I'm
Huh?
taking multiple questions. So the reason I'm asking is because for me it matters what you measure. For example, most of the times the business asks for features and we are, trying to improve around that.
I understand.
So I guess when you say bunch of work to one department to another, you don't mean features, right?
Correct.
So
A release candidate is a batch of features, normally.
okay. So, but taking this into account, if feature 1 is a lot bigger than feature B,
Yep.
then you cannot stick to the same lead time because you have in the work the amount of work to create that feature.
Okay, I understand.
So this is a confusion me. What you're measuring, I guess, and the second question, how you did that? How you measured waiting time versus processing time on this batch of work? What is this batch of work?
Those are 2 really good questions. So in case anyone didn't hear, the first question was, why are you not measuring the time it takes for individual features to go out to customers, and how do you do it? And the second question was, how do you measure the difference between wait time, queue time, and process time? I actually try not to call it wait time because people get quite emotive about that. Like if you go to some database administrators and say, there's a wait time of 50 minutes before you start your work, that sounds awfully close to lazy time. So I tend to say queue time, which is a bit less emotive. Don't do what I did, which is once send an email to some database administrators on New Year's Eve saying there's a 50-minute wait time. Like, they don't like that. That was a mistake. So you can measure feature time, and you should, but that's really out of the remit of continuous delivery. Because then you want to look at product design and development as well. So there's a lot of confusion often around what cycle time is. That's what cycle time is, the time it takes a feature to go from inception to customer. Okay, that's cycle time. And you can absolutely measure that, but that's beyond your technology value stream. You want to be doing that probably from the time the ticket first lands in Jira or SharePoint, whatever the hell it is you use. Okay, it's that thing from light bulb to customer. With continuous delivery, we're looking from version control to customer. So your deployment lead time will be a segment within your cycle time. Okay, and it's entirely possible that with cycle time, you will have a constraint upstream before the continuous delivery space. Okay, perhaps features are sitting around in the backlog for ages before a product owner decides what to do next. Okay. So with continuous delivery, we're trying to measure a release candidate, a batch of features that go out. And if you have 2 features, one takes a week, one takes a day, then they'll both have a lead time of a week because they're going out in the same release candidate and your batch size is too large. Okay? So the second point around the difference between queue time and process time, the easy way to do that is to look at the start and stop time of individual activities, okay? And then the time in between the end time of activity 1 and the start time of activity 2, that's the queue time for activity 2. Okay? It's really not as hard as it sounds. And if you want to do just like a one-off exercise, then just do a value stream mapping. Get everyone in a workshop, get a whiteboard with some sticky tape. Sticky tape? Yes, you should tie everyone up and then do it. Get some it's hot. Get some sticky notes. Just put up on a board, which activities do we do, and roughly how much time do you think each activity lasts? And then once you've done that, the gaps, the remaining time, that must be the gaps, right? So Dan North has a great line around, if you don't slap your head when you're measuring this stuff, then you're doing it wrong. As in when you do it, you'll be like, oh my God, I can't believe it's this thing. So with that network activation thing, that did really happen. All I've changed the name of the company. I did learn years later that it had been this paperwork thing. And that really blew my mind. And the only reason I found that was I learned to measure the queue time between operations team saying this is ready to go into production and someone actually pushing the button. Previously, I've just been measuring the process times going, it doesn't take long to test it, it doesn't take long to deploy it, where's all the time going? Okay? If you want to have a chat about it afterwards, I probably have some data and some stuff I can show you.
Thank you. One more question before we go for coffee break. I think they go. One more question, guys.
Hello.
Hello.
You mentioned before that you identified the obstacle as the work that the release manager was doing. Mm-hmm. What if the release manager is stuck on it and wants to do that work, and he is not willing to change the way he works? Maybe that's another obstacle, actually.
Are we still filming? Are we filming Q&A? He's looking at me, and I think we're still filming. So I'll answer this question very carefully, I'm afraid, but you can always chat to me afterwards. So that can happen, and when it does, it's really difficult, because in that case, probably what's happening is that person is incentivized to be busy. People are being measured by utilization rate, like in the theory of constraints, Dr. Goldrup points out how pointless it is to measure people by their individual productivity. But people often are encouraged to feel like they're not of worth or of value to an organization unless they're working flat out. That can totally happen. And when that happens, I think the most important thing is to invite someone into a conversation, and I stress the word invite. If somebody doesn't want to participate, then that's okay. If you make an offer of help to someone and they decline it, then that's okay. And you should go back to your sponsor, whoever it is, and say, here's the offer I've made, here's the conversation we've had, here's the outcome this is going to lead to. I'm okay with that. What are your thoughts? Okay? Saying to someone, you're only saying that because you're incentivized to go at utilization won't help. Quoting books at them won't help. Showing them videos of me talking about this stuff won't help. It's just really about like you and that person having that conversation and really listening to their problems. When I've had success in the past with that, it's because I really understood why the person felt that they had to do those tasks. And it is a very delicate thing to say to someone, we're going to take some work off you. Especially if it's a really big company and they're worried about being moved around or laid off or whatever. So yeah, tread carefully, speak with someone honestly, transparently, show them your data. Don't speak to the release manager last, speak to them first. I wasn't joking when I said make friends with the release manager. Is that an okay answer? You're kind of doing that bird thing of like, yeah, that's kind of okay. Okay. Anything else, or are we out of time?
Great. We're off for a coffee break now, so you can grab Steve over coffee, and we meet back here at 4:30. Yeah, and this is a little something for you.
Oh, thank you. That's not necessary.
Agile.
Having me in Greece was a gift enough. Thank you. And you should come back here. The next speaker, Emily, is just awesome. So you should definitely come to that.
Thank you.
Thank you.